Okay, so yeah, I'm going to talk to you guys about my one of my favorite architectural patterns, hexagonal architecture, or ports and adapters, as it's also called, and how that can be used to make your applications or services really testable. So let's get started. So I'll start with the intent of the pattern, the intent of the hexagonal architecture. So the idea with it is to allow an application to equally be driven by users, programs, automated tests or batch scripts, and to be developed and tested in isolation from its eventual runtime devices and databases. So this is kind of the nice description that Alistair Coburn, who's the inventor of the pattern, or at least the documenter of it, wrote in his blog entry from 2005, 2006. So, so this is what we're going to look at and see how it can be used. So, yeah, the name of it, why a hexagon? Well, the idea here is that compared to a traditional layered architecture, which is fairly common, we want to emphasize the not the layers and how they depend on each other, but rather the outside versus inside of an application. So that's part of the pattern, and also that we want to have more than just top and a bottom or a left and a right, to show that that you can have multiple ports or multiple things that connect to your application and that you connect to. So and then why 6 sides? Why the hexagon? Well, according to Alistair, that's the simplest non-square thing that you can draw easily on a whiteboard. So it's kind of accidental, but quite practical. So typically the visual format of it is related to comparing it to layered architecture that was which is still quite a common alternative. Through the presentation, I'll try to use a fairly simple example application, and it's one that I'm pretty familiar with, and that's the small service that's in the back end when someone registers for a course at CRISP. So so the example will not be exactly true to the real world, but it's a nice small sample anyway. So how does that application work? What problem are we trying to solve with it? So basically, someone wants to register to a course. There's a very simple HTTPS post from our website. The service needs to check for the course, the availability, and then store the actual registration. And after that, there's also a need to notify both the participant that they were actually registered to the course, and also the teachers or trainers that someone had signed up. So these 3 pretty simple steps is the core of the application and what it does. Typically, well, I mean, this is a real world application, but most services that we see at customers are of course much more advanced and faster compared to this. But anyway, well, using this pretty simple example makes it easier to introduce the concepts. And yeah, I see the question whether hexagonal architecture is the same as clean architecture. They're similar in some respects. Hexagonal architecture has fewer rules and focuses on the really important parts, in my opinion. But they're quite symmetrical. They share a lot of the same concepts. So they're not opposites in any way. Thanks for the question. Okay, so another thing I'll be looking at is that our little registration service, it's been around for more than 10 years, and it's gone through a bit of technology evolution during those years as well. So it started out as a Spring 2.3 Tomcat application with the MySQL database, configuration files in XML, and sending emails through SMTP. So that's, and through the years, well, we've added integration to Google Sheets. So basically making it easier for us to find out who's registered. We just, well, the system stores the registrations there. We found out that we could get rid of the extra database and the XML configuration, reducing some dependencies. And a couple of years ago, when Google notified us that they were shutting down Google Sheets version 3, and we had to migrate to version 4, we took the chance to kind of revamp the system, upgrade to a more modern stack, and yeah, refresh it a bit. So basically, this is just an example of an application going through technology changes while keeping the basic business concepts through the time. So what does that mean in terms of architecture and things like, yeah, right. Another thing is, so with these systems, we want to store things in Google Sheets. We want to send email through the Gmail API. How do we test it? That's basically one of the challenges that the architecture helps with. So, so one option would be to try to verify the real emails sent and the real Google Sheets stored. That's definitely possible, but it's really, really slow. The tests become quite complicated. And when running the test, you would need Google account credentials. So it's typically not something that you would run on each commit or pull request because it takes time. Another alternative would be to add mocks for the APIs, the Gmail and Google Sheets APIs, instead of using the real thing, just verifying how we interact with it. That would end up with a really complicated test setup, and it would couple our tests to implementation details in those APIs. And it may also give false confidence because we would be making up how we assume that the actual API implementation behaves. So that's kind of the background to the challenge. So now I'll dive into the actual content. So in the hexagonal architecture, or ports and adapters, both names are used interchangeably. There's a focus on an application core, and then there are well, the actual interactions with the system on what's usually called the driver side. There's a driving or primary actors. On the driven side, you have the secondary or driven actors. So basically, driving actors are the actors that call the system, and the driven actors are the systems that are called by the application. And one key thing in the architecture is that all the business logic is supposed to go inside the application core. That's kind of the primary thing. And then the ports in the ports and adapters are the actual application boundaries. So those are how you talk to the application or how it talks to the other systems. And then the adapters are technology components that translate between the outside technology and the ports. And also the ports are, I'll go into it a little bit deeper soon, but they are kind of defined towards an interaction with an actor. So driver adapters, like in this case, the web app registration controller calls the application through what's called the driver port. And the driven adapters, they implement the ports. So the ports are actually defined inside the application, and the adapters are outside and connect to it. And to then achieve good testability, what you do is that you can implement test-oriented adapters. So instead of talking to the real outside dependency, you have a fake adapter, but it implements exactly the same, uses the same port as the real thing. And then to keep the actual application core clean, and that this is where it's very similar to the clean architecture. All the outside dependencies are provided to the core components from the outside. So conceptually, the application core does not know about the details on the outside. So how do we define the ports? Well, ports should be defined based on purpose. And a port is defined for the interaction between a particular actor and that conversation towards the application. And it's based on the purpose of the interaction, not the technology used. So in this case, when we register participants, we have a port, well, actually named as well for registering participants. So it doesn't know anything about it being a web request coming in, or that it's a Micronaut web controller, which might be the adapter there. So the port is just defined for actually receiving participant registrations. Similar, we have a port for getting event configurations. That's where we define what date it is and number of possible participants and things. So that's one port. And there's another port with the purpose of storing registrations. So even though these two ports actually go to the same backend service, which is Google Sheets, they're separate. And going through the history of this application, at one time we actually read the configurations from XML files, and we stored the registration in the database. So by keeping the ports focused on the purpose, they're more resilient to changes. And then the last port in this application is for sending email. And this here you could question the purpose. Is it really for sending emails, or is it for notifying teachers and participants? And this is kind of a trade-off. In this case, making that abstraction, not actually sending an email, but sending a notification, would make this pretty simple application much too abstract in this case. If in the future we need to add more different ways to notify it, then we will probably refactor it and make it more abstract. So, and then the ports should also be using application terms. They shouldn't be about the technology. They should be about the system, well, the logic that you're building. So, in practice, our application has well, these 4 ports. It has 2 major, important classes, components on the inside. A service that implements the for registration participants port, and a notification handler for sending emails. So it's a really simple thing. Code-wise, the pattern itself doesn't really say anything about how you should structure your packages or classes. But it makes it easier to work with if you kind of decide on a pattern. What we've done in this particular case is having one package for the actual application core. It's called core here, and then one package where all the adapters are. And then depending on the technology stack you use, you might need some configuration classes for instantiating adapters and providing them to and kind of connecting everything. This really simple application using Micronaut kind of gets that for free from the Micronaut framework, though. And if we expand these packages, you can see that in the core package there are 4 interfaces, 1 for each port, and then the major components and all the support classes. This could, of course, be well, we could add some more specific packages to structure it better. If there were a few more classes, that would probably help, but it's so simple now. And then I've expanded the Gmail adapter package where there's a really simple adapter Gmail sender. Okay, so when automating tests here, what are the options? Well, for functional acceptance or scenario tests, what you can do is that you substitute the production adapters with testables, so that you can test the application logic really easily. And for those testables, you could decide whether you want to use a mocking framework or if you want to build your homegrown in-memory fakes. It depends on the complexity of the port and whether you like mocking frameworks or not. One of the good benefits here is that it's really easy to control and observe the whole business logic. And since all the business logic is inside the core, you can execute all your functional tests for how the application should behave through these APIs. For integration testing, what you can do is that you isolate the actual adapters and write integration tests for how they interact with the real dependencies. Let's see, I have a question here. Right, so I'll answer the question. For the naming convention for the ports, there is not really a universal convention. There is a kind of a fairly recent discussion on naming them kind of intentionally for the purpose rather than for the concept behind the interface. So I've seen Alistair and some other people writing blogs and doing presentations just using the for doing something naming convention. But I think it's still quite rare out there in real life. Mostly you find naming either based on DDD naming conventions like repository for driven adapters or driven ports where you both save and load things. But anyway, yeah. So there's a kind of suggestion, but thanks for the hint. Right. So for integration testing, we write integration tests with the adapter isolated, because then you can separate it from all the business logic concepts and cases there, and just focus on what that adapter code should be doing and how it works with the real system. Another nice thing with this is if those integration tests are slow and require credentials and stuff, you really only need to run them when you make changes to the adapter, or when there is a change in the underlying technology. So that's nice for a test isolation as well. And then to actually know that your system works for real, you should complement this with some real end-to-end scenarios in the real environment to verify that everything fits together properly and that you haven't missed anything. But that's, yeah. But anyway, it makes the testing of business logic much easier with the setup. Okay, so let's check the time. Max, how much time do I have? So
you have 6 minutes if you want to talk all the way to the end without questions.
Okay, so I'll make it fairly quick then. So let's see. So just checking, do you see my IDE now instead of the PowerPoint?
Yes.
Okay, good. So so I'll just do a very quick look here. Let's see. So basically, the 4 ports. On the left side, we have for getting event configurations has a really simple method, find event configuration, taking a string, returning an event configuration. This shows, one pattern here is that I try to use value objects when sending objects data through the API. So the event configuration, let's see, is okay. One of the other objects, registration info, is a value. So basically, it's an immutable object. In this case, I'm using Lombok as a framework. But basically, the code defines what this class can do. So the adapters can't make a mess out of our application code. A somewhat wider port is for storing registrations. It has 3 methods. One to know how many participants we already have for the event, and then one for accepting a participant to the event, and one for putting the participant on the waiting list. So it's pretty straightforward, but it's this port is all about the business logic, or I mean, it's defined based on the application, not about how the technology is then saving it. And one quick other class. So this is a slightly bigger class. So this is the actual scenario test for this. So this has quite a bit of code, but not too much, because it's setting up the fake, and in this case I've used in-memory adapters. So basically there's a test for accepting registrations to an unlimited event. So basically, if there's no max number of participants, we don't need to check how many were registered, but we can just store it. And then it verifies that the emails are sent correctly as well. And what else? And then there are other tests for well, storing a participant properly if there is a limit, but it's not exceeded yet, and one for, well, if the course is already full, then we store it as on the waiting list and send a different email. So those are, I mean, the application is really simple, so it's not a lot of code either, but it's really easy to just verify the whole thing at this level. And let's see. Yeah, so and that about the value objects. This is the definition of an event configuration retrieved from the system. So it has some data, which is immutable, but it's perfectly fine to have logic in those classes as well. They don't have to be dumb structure objects. So you can, and since they are actually defined on the inside of the application where we have the business logic, that's perfectly fine. So that's a little bit about the code. And on the question of whether I would share the example code on GitHub, well, the thing is, since I mean the project I'm showing right now is just an example project, but it's also based. It's not too far from our production code, so I would need to go through and clean it quite a bit before sharing it. So that was not my plan, at least. Okay, so hopefully back to the presentation. Right, so finishing up with a few quick design reflections. Stick to the rules of the pattern, but keep it lightweight. I've seen suggestions to separate every adapter to a separate module and all things. You can do that if you want to enforce the rules, but you get the value of the pattern by just following the rules. Start simple. I mean, just using packages is pretty lightweight. When designing ports, let's see. Okay, so yeah, see, I'm out of time. So I'll try to close with a very, this is the last slide, so I'm almost done. So yeah, so have a port that is rather wide rather than have a deep API structure with a lot of intricate API calls, because those are much harder to test. And lastly, yeah, use immutable value objects for parameters. That makes everything easier to test. And yeah, so that was what I had. I'll stick around in the break to answer any questions. Sorry for going over. Thank you.
I think we're okay. Thank you very much, Fredrik. Really nice talk. And as Fredrik said, he'll stick around for a bit. The next session starts in 5 minutes, so I hope to see many of you back then. Thank you.
Right. So yes, so I saw the question on whether ports and adapters can be applied to PubSub and event sourcing. Yes, it works really well there. So basically on the driver side, an incoming message is typically a driver, and on the driven side, sending a message is typically a driver port. Also, if you look at things like event sourcing or CQRS, basically the split between the separation between command and query is typically a natural place to separate into two different ports as well. So then you have a command, so one port for issuing commands and one for making queries. Of course, those should be defined from the actual purpose and the of the application. But yeah, so the pattern is very well suited for switching out things. So, for example, in our course registration application. Right now, we only serve HTTP requests, but technically, if we added an adapter to receive registrations over email, we would read that email, parse it, and then just call the port for registering participants, and the rest of the application wouldn't be affected at all. So we could kind of add multiple input sources without changing the logic there. So that's part of the really other properties. And also, like, when APIs change, like Google shutting down version 3 in favor of version 4, if we had a proper ports and adapters architecture at the time, we would only need to change that adapter. Okay. I'll be silent for a while to see if someone wants to ask something.